Hello students, welcome to our student support program for grade 11. Today, in mensuration, we are going to learn how to find the volume and surface area of a cylinder. The surface area of a cylinder. For the surface area of a cylinder, it is best to visualize the net of the solid. It is made up of one rectangular piece when we unfold the curved surface, and two circular pieces depending on the type of the cylinder. The curved surface unfolds into a rectangular piece with length 2 pi r, the circumference of the circular base of the cylinder. The surface area of a cylinder. Area of the circular pieces is equal to 2 multiplied by pi r square. Area of the rectangular piece is equal to 2 pi r multiplied by h. Therefore, area of cylinder is equal to 2 pi r square plus 2 pi r h. The surface area of a cylinder depends on the types of the cylinders. Type 1, closed at both ends. The total area is equal to 2 pi r square plus 2 pi r h. Type 2, open at one end. The total area is equal to pi r square plus 2 pi r h. Type 3, open at both ends. Total area is equal to 2 pi r h. Example 1. A pipe has a radius 5 centimeters and length 10 centimeters. Calculate the surface area of the pipe. Take pi to be 3.142. This is a type 3 cylinder. Open at both ends. To calculate the surface area, it is 2 pi r h. Substituting the values, we get 2 multiplied by 3.142 multiplied by 5 multiplied by 10 centimeters square. Evaluating this, we get 314.2 centimeters square. Rounding this off to three significant figures, we get 314 centimeters square. Example 2. A cylindrical glass has radius 3 centimeters and height 7 centimeters. Calculate the surface area of the glass. Take pi to be 22/7. Now this is a type 2 cylinder. Open at one end. The total area is equal to pi r square plus 2 pi r h. 22/7 multiplied by 3 to the square plus 2 times 22/7 times 3 times 7 centimeters square. Evaluating this, we get 160 to 7th centimeters square. Example 3. A cylindrical can has radius 2 centimeters and height 12 centimeters. Calculate the surface area of the can. Leave your answer in pi. Type 1. Closed at both ends. The total area is equal to 2 pi r square plus 2 pi r h. Substituting the values, we get 2 pi multiplied by 2 to the square plus 2 pi multiplied by 2 multiplied by 12 centimeters square. Evaluating this, we get 8 pi plus 48 pi, which is equal to 56 pi centimeters square. Next, we have volume of a cylinder. Note that irrespective of type of cylinder, be it closed at both ends, open at one end, or open at both ends, the formula to calculate the volume remains unchanged, since the space that it occupies remains the same. Therefore, volume of a cylinder is equal to area of cross-section multiplied by height, which is equal to area of the circular base multiplied by height, equal to pi r square h. For example, calculate volume of the cylinder shown in the diagram. Volume of cylinder is equal to pi r square h. Substituting the values, we get pi is equal to 4 to the square multiplied by 25 centimeter cube. Evaluating, we get 1256.63 centimeter cube. Rounding this to three significant figures, we get 1260 centimeter cube. Note that this is a Cambridge instruction. Give non-exact numerical answers correct to three significant figures unless a different level of accuracy is specified in the question. For pi, you can use either your calculator value or 3.142. Next example. The net is folded to make a solid. Part A. Name the solid formed when the net is folded. Part B. Which vertex joins with A? Part C. Find the length of AB. Part D. Find the volume of the cylinder formed. Take pi to be 22/7. Part A. Name the solid formed when the net is folded. The edges AC and BD will be joined forming a curved surface, and the ends will be closed by the two circles with radius 6 cm. Hence, once the net is folded, a cylinder is formed. Part B. Which vertex joins with A? When the rectangle ABCD is folded, the vertex A will be joined with vertex B to form a curved surface. Therefore, vertex B joins with A. Part C. Find the length of AB. When folded, AB represents the circumference of the cross-section of the cylinder. Therefore, AB is equal to 2 pi r. Substituting the values, we get 2 multiplied by 22/7 multiplied by 6 centimeter, which is equal to 264/7 centimeters, which is equal to 37/5/7 centimeters. Find the volume of the cylinder formed. Volume of cylinder is equal to pi r square h, which is equal to 22/7 multiplied by 6 to the square multiplied by 21 centimeter cube, which is equal to 2376 centimeter cube. Next example. The diagram shows two circles, both with center O. The radius of the small circle is 3 centimeters and the radius of the large circle is 6 centimeters. The minor sector XOY has an angle of 50 degrees. Find the total area of the shaded region. Part B. The diagram of Part A is the top and bottom design of a cylindrical jewelry case with height 15 centimeters. The curved surface is also shaded. Calculate the total surface area of the shaded region. Give your answer to three significant figures. Total area of the shaded region is equal to area of outer shaded ring of a large circle plus area of minor shaded sector of small circle. Area of minor sector X or Y. 50 over 360 multiplied by pi multiplied by 3 square centimeter square is equal to 3.92699 centimeter square. Area of outer ring is area of large circle minus area of small circle. Pi multiplied by 6 to the square minus pi multiplied by 3 to the square centimeter square. Evaluating this, we get 84.82300 centimeter square. Area of unshaded part of the outer ring is equal to area of large sector X or Y minus area of small sector X or Y, which is equal to 50 over 360 multiplied by pi multiplied by 6 to the square minus 50 over 360 multiplied by pi multiplied by 3 to the square centimeter square. Evaluating this, we get 11.78097 centimeter square. Area of outer shaded ring of large circle is equal to area of outer ring of circle minus area of unshaded part of the outer ring, which is equal to 84.82300 minus 11.78097. Evaluating this, we get 73.04203 centimeter square. Next, the total area of the shaded region, area of the outer shaded ring of large circle, plus area of minor shaded sector of small circle. Substituting each value, we get 73.04203 plus 3.926699. Evaluating, we get 76.96902 centimeter square. Rounding this off to three significant figures, it is 77.0 centimeter square. Next, part B. Total surface area of the shaded region is equal to 2 times area of the shaded cross-section plus area of the curved surface, which is equal to 2 multiplied by 76.96902 plus 2 times pi times 6 times 15 centimeter square. Evaluating this, we get 719.4247 centimeter square. Rounding this off to three significant figures, we get 719 centimeter square. Now that we have done some examples, here are some exercises for you to practice. Students, today you have learned how to find the volume and surface area of a cylinder. I hope you have enjoyed it. See you next time.